Hello students, and welcome to today's chemistry class for S.S.1. In today's class, we will look at the topic kinetic theory of gases.
But before we proceed, I would like to tickle your fancy a bit. Light travels faster than sound. No wonder some people sound bright until they speak. You understand? You get the drift. So let's now take a look at our lesson objectives. At the end of this lesson, the student should be able to state the kinetic theory of gases, explain the postulates of the kinetic theory, mention 3 physical states of matter. The kinetic theory of matter states that matter is composed of a large number of small particles that are in constant motion. In other words, kinetic theory of matter recognizes that matter is composed of small particles, ions, atoms, and molecules, whose different pattern of arrangements and motions results in the different possible states in which matter can occur. Now, there are 3 physical states of matter. These are solids, liquids, and gases. Now, substances can change from one state to another. Let's now take a look at the solid state of matter. Solid particles can vibrate, rotate about a mean position, but cannot translate. What this means is that the particles in a solid can vibrate, they can rotate, but they cannot move from point A to point B. Now, solids have a fixed shape and cannot be compressed. So let's now take a look at the liquid state of matter. Liquid particles can vibrate, they can rotate, and they can translate, but within forces of adhesion and cohesion. What this means is that the particles in a liquid can actually rotate, vibrate, and then move from one point to another, but within certain forces. Now, that is the reason why a liquid can flow, because in as much as they are moving, but they are still being held together by some forces. A liquid does not have a fixed shape. It normally takes the shape of its container, and it cannot be compressed. The gaseous state of matter. Now, gas particles can vibrate, they can rotate, and they can translate without any force hindering them. Now, you can see the basic difference between the solid, liquid, and gas. That the gas does not even have any force holding its particles together. They can move to wherever they want to move to without any force hindering them. Now, a gas has no fixed shape and can be compressed easily. Assumptions of the kinetic theory.
The assumptions include the collision of gas molecules are perfectly elastic. When 2 individuals collide, the individual energies may change and one may move faster than the other, but the total kinetic energy remains the same. So in some books, they will tell you that the collision of gas particles is perfectly elastic. Now, the cohesive forces between the gas molecules are negligible. And another assumption is that the temperature of the gas is a measure of the average kinetic energy of the gases. In other words, the kinetic energy of the gases is directly proportional to its temperature. Another assumption is that gas molecules move randomly in straight lines, colliding with each other and with the walls of the container. The collision of the gas molecules on the walls of the container constitutes the gas pressure exerted on the container. That is, the pressure on a container depends on the level of collision of the gas molecules against the walls of the container. Let's take a quick summary of today's class. We have learnt about the kinetic theory. We have learnt about liquids. We learnt about solids and gases. It's now time for a quick assessment. Water exists as a solid, liquid, and gas respectively because water is colorless, water is electrovalent, water in any state possesses a certain degree of motion in molecules. Water is molecular. Which of the three states of matter has no fixed shape, no fixed volume, and less dense? A. Gas, B. Liquid, C. Solid, D. Crystal. Question 3. The escape of molecules with more than average kinetic energy of the molecules is called A. Melting, B. Freezing, C. Evaporation, D. Efflorescence.
And so, with this, we have come to the end of today's lesson. Thanks for watching and see you in the next lesson.